In this video clip, we'll take a look at the hydrolysis of an imine to form a ketone. Now this is an equilibrium reaction. An imine is a carbon-nitrogen double bond, a ketone, carbon-oxygen double bond, and they're going to be interchangeable in the presence of water and acidified water. So let's take a look at this mechanism. We're starting off with our imine, and we have H3O plus and H2O. This oxygen is positively charged, not a happy oxygen. It wants to suck recover a couple of electrons. This nitrogen has a lone pair of electrons right here. So the first step is going to be to protonate the nitrogen of the imine, and we're going to go ahead and have that protonated. And now this nitrogen is positively charged. We have water. I'm going to show that over here, and we have our water molecules. And now at this point that nitrogen is positively charged, nitrogen is electronegative, it wants to recover some electrons, but before I do that, this is actually an equilibrium reaction because this water can come right back, pick up that hydrogen, push these electrons back on the nitrogen, so I do have to make that an equilibrium arrow. Now to move forward though, I could have the oxygen gets sucked in over here, attack the carbon of the imine, push the electrons up over there, and now I have this species where I have a nitrogen which has recovered a pair of electrons. We'll put them there. We have the hydrogen and the ethyl group on that nitrogen. We have our water molecule that now is over here. We have that the oxygen's dragging the two hydrogens with it, so that oxygen's positively charged. And we have our other water molecule here. Now, once again, this is an equilibrium step because this oxygen that's positively charged, not happy. These electrons can come right back down, kick that back off, and now we're back to over here. At this point, we want to deprotonate this oxygen. A water molecule will come along, pick up hydrogen. These two electrons, the oxygen recovers its lone pair of electrons, and now we have a neutral species. The nitrogen, I'm going to kind of redraw this a little bit like this. Hydrogen, just so it looks prettier. And I have an oxygen, and the oxygen has its two lone pairs of electrons. We're back to H3O plus here, and H2O, that there, H3O plus. Okay, so we're good to go. At this point now, this is also, once again, equilibrium because this oxygen can go right back, pick up one of those hydrogens and revert back. The other option though is to have this nitrogen now, lone pair of electrons, go ahead and get protonated. And we're going to go down over here. So now I have a positively charged nitrogen, there, like that. And I have my OH group right there. I have water here. Once again, this is also equilibrium because a water molecule can come right back, pick up one of these hydrogens, revert back to that. But at this point, to move forward, we have this nitrogen's positive, so that's a decent leaving group. This oxygen over here has a lone pair of electrons that can swing down, push these electrons up to there. I'm going to go down one more step, and I'm going to have, now I will have, you can see the ketone is kind of on its way. We have the double bond to the oxygen. Coming out is the nitrogen with a lone pair of electrons, two hydrogens, and ethyl group, and water, HOH. But once again, this is also equilibrium because this nitrogen could come right back, push those electrons up. There we go. And then finally we have this water molecule coming in over here and pushing these electrons onto that oxygen right there, and giving us our final product. I'll draw it over here, which would be our ketone, our H3O plus here, and our amine. Hydrogen, hydrogen, right there. And this is, of course, equilibrium, because then this oxygen can get protonated again and go right back. That's the full mechanism. Now you can shift the equilibrium using Le Chatelier's principle. If you start putting extra water in there, it's going to force towards the ketone. If you start sucking out the water, then you're pulling out a reactant and it's going to come backwards. You're going to shift it from the ketone back to an imine.